Have you ever downloaded a shiny new program, only to realize it wants you to cough up some cash before you can use it? We've all been there staring at that paywall. You might even have been tempted to venture into the dark web of the internet to find the solution.
Before we continue, let's talk about Rolladell.com. This is not another freelance marketplace. Rolladell was built for freelancers who value freedom, privacy, and control. This is where individuals and businesses of all sizes post their service and get hired in a flexible manner. Design, programming, copywriting, SEO, social media, marketing, and much more. There's a professional client waiting to pay for your service. After you've signed up, create proposal, describing your project by telling clients about your proposal. Boom. Receive messages from interested clients and work with them. Guess what? You can become a buyer and purchase services with your local payment options. You're in control. Visit Rolladell.com to get started now.
But have you ever wondered how these activation mechanisms actually work and how hackers or crackers manage to bypass them? Programs are written in languages like C++, Java, and Python. These languages are super friendly for humans, but absolute gibberish to computers. To bridge this communication gap, the code gets translated into machine code, a glorious mess of ones and zeros that your computer can finally understand. This transformation process is called compilation. Now this machine code can be displayed in assembly language, which is basically machine code with a slightly better outfit. It's still pretty close to the hardware, so instead of high-level commands, you get to deal with cryptic instructions like move EB23, which is just a fancy way of telling the computer to put the number 23 in the EB register. Software activation checks come in two flavors, online and offline. Online checks are the nosy ones. They verify your ownership by chatting with the server, somewhere out in the cloud. You type in your key and the software sends it off along with the unique identifier of your machine. The server checks its list, and if your key is legit, it sends back a thumbs up and your software is activated. Offline checks, on the other hand, are more like an introverted puzzle. The software uses an algorithm built into itself to verify your key. When you enter your activation key and email, this algorithm does its thing, checking the key against some internal rules. These algorithms can range from simple, like checking a basic pattern, to brain-meltingly complex involving cryptography and stuff that makes you wish you'd paid more attention in math class. Enter the crackers who make it their mission to bypass these activation mechanisms. They use reverse engineering, which is a fancy term for taking the software apart to see how it ticks. To do this, they wield tools like disassemblers and debuggers. Disassemblers turn machine code back into assembly language, making it slightly more readable. Debuggers let crackers run the software step by step, pausing at will to poke around and see what's happening under the hood. The process usually starts with the cracker hunting down the activation code, often by searching for telltale strings like invalid key or activation required. Once they've found the code, they study how it works. This might involve checking specific bytes, calculating a checksum, or decrypting some data. After understanding the activation process, they tweak the code to bypass it. This can mean replacing critical instructions with NOP, no operation commands, or changing conditional jumps to alter the program's flow with the code. Modified crackers create a patched version of the executable, often distributing it alongside the original installer. Users then replace the original executable with the patched one, and they've got a free, albeit illegal, copy of the software. But software developers aren't just sitting around twiddling their thumbs. They've got tricks up their sleeves to make reverse engineering harder. Code obfuscation makes the code look like a tangled mess of spaghetti. As an example, I'm going to crack a reverse engineering crack-me program. Just a heads up, these crack-me's are made specifically to be cracked. They're not real programs. They're designed for this purpose. I'll be working on a crack-me called Pride Crack by Pride. It's written in C or C++ and is a 32-bit program. I'll be using X32DBG for this. If you don't have X32, make sure to download it. First, let's open the program and see what it does. It asks for a name, so I'll enter Bob. Then it asks for a serial key. I'll enter a random key like 1, 2, 3, 4, 5, 6. It says false serial key and exits. Now we know the program uses the msvcrt.dll system call to handle this. Let's search for that in x32dbg. Once we find it, we'll start looking for the right serial key after opening the program in x32. I'll search for intermodule calls and find the msvcrt.dll system. Double-clicking on it, we find some code related to the serial key check. We see a compare instruction checking the user input against a stored value. We need to make sure this comparison passes. I'll set a breakpoint at the jump if not equal instruction and run the program again, entering Bob in 1, 2, 3, 4, 5, 6. When the breakpoint hits, I'll check the values being compared. We see our input 123,456 being compared to a stored value. The stored value is calculated using the length of the name and some arithmetic operations. Let's find out how this value is derived. The name length is stored in the EAX register and some operations are performed on it. I'll use Python to recreate this calculation. Let's assume a name with 5 letters like bread. The length is 5 and we add 0xk to it. Then XOR with 0x3d 8040f. Here's the Python code to generate the serial key. The generated key can now be used. I'll restart the program, enter the name bread, and use the generated key. It works, and that's how we crack this program using x32dbg. Now here's the serious part. Using cracked software is illegal and it's risky. You could face legal consequences, and cracked software often comes with unwanted bonus features like malware. Plus, you miss out on support and updates, leaving you vulnerable to bugs and security vulnerabilities. So while the technical wizardry behind bypassing software activation is undeniably fascinating, it's best to stay on the right side of the law. Thanks for watching, and as always, stay safe and subscribe to Policy Point.